Hi, I'm Paketa12. This is another exclusive tutorial for you guys. Thank you so much for supporting me. Today we go back on collisions and we'll take it into 3D in order to solve the self-packing spheres as you see here in this file. And we build this with a couple of parameters. You can change them on the go. So if we want much more spheres, we can have that and decrease the radius, let's say, and yeah, we still have a very nice FPS here. And yeah, let's build this. So I close here and I leave it aside to guide me if I do something wrong. So we'll start clean in a new container. Okay, so let's first grab a count chop. Okay, not a count, a constant, sorry. So constant, and we need count being the number of spheres, and let's say 12 for now, and radius and 0.325. This one actually is not a radius, is they all have different radiuses, and this one is just a multiplier. So what else? We need speed. So 0.1. Okay. And from here, let's chain a null, and I'll make this a little bit bigger, and in between another null, and with collapse selected we have a folder, and inside let's grab with a select chop, grab a count, and I wanna find out the minimum resolution for a square texture to have 12 points in it. So that would be my map size, and I use a math chop with root and also ceiling, and now I have my resolution with merge chop here. Okay, and now if we go back, we can grab a noise stop. Okay, and here nearest pixels 32 RGB and not monochrome. Now we have our points. Actually we have 16. So let's chain a null here, and since we need to find out distances from one to all the others, we need those pixels right here in a linear texture. And yeah, let's make a folder here and take care about that. Okay, so we use a null. Okay, and select collapse selected, and this one I can say one line. Okay, let's go inside, and out of this null right here, let's take top 2, and we don't need alpha, and also a shuffle. And here we have shuffles, sequence channels by name, and here we take full image. Okay, and now if I take a chop to out and set RGB, okay, let's go for the nearest pixels. Okay, now I have the points in a linear texture, and yeah, this is good since we need to compute distances. Okay, what else we need? We need another noise. This one, black and white. Okay, and this would give us the radius value, which will get multiplied by this, and it will be the final radius. Okay, and we also need this texture being linear, so let's copy past this folder here. Okay, and we need another null, and yeah, I will make this a little bit bigger, like this, let's say. Okay, so this is position, and this one radius. Okay, and now I will also want to cut out the points that I don't need, so here I only need 12. Let's use a group. Okay, and here set pixels and grab the count instead of 16. Another one for the noise. Okay, I will set those two also on nearest pixels. Okay, and as said, I will multiply these values, okay, with this radius multiplier, because now they are quite big, and we use math here. Okay, and yeah, we multiply with this, and also we'll take nearest pixels. Okay, now we good. Let's use here two selects top. One will take the position, and another one will take the radius. Okay, and what else? Yeah, we can use reorder and have the radius instead of alpha. For that we choose RGBA and nearest pixels, and here alpha will take input to red value. Okay, and now we chain a null, and we instance a sphere. Okay, so let's grab a sphere SOP. Okay, this one will be polygon, and here we go with 6. Geometry. Okay, and I'm using experimental version, so I can instance out of a texture. I will do this right now. So I use this texture here, and on translate X I'll take R and then G, B. Okay, and here on scale I will take A. Okay, let's split the screen now, and geometry viewer. Okay, now I have my spheres. Some of them are overlapping, and you see this one here, it's quite black, and this is because the value here for the radius is getting negative, and we don't want that. So here in the same operator where we use that multiplier, we also set everything on positive. Okay, and now we good, and we would like to have these spheres moving. For that we have this speed right here, so let's go inside this base, and we use a select chop. Okay, we grab that speed, and we rename this in time. So now I use speed chop, and we have that time also in this merge. And now if I use that value here for translate z for the points, now we have some motion. Okay, let's center this here by setting the offset to 0, and yeah, we good to go. But before, I want to analyze here what we did, and decide if it's good or not in terms of performance. So we use the top to chop bridge 2 times, and yeah, we know it's a little bit slow, but in fact it's not slow. When you're dealing with less than, let's say, 1000 points, it's quite fast, and you can have this if you don't plan to for a crazy amount of pixels. Okay, but also I'm thinking to optimize this, and maybe not using this bridge 2 times. Let's see how we do that. Okay, because it seems like the difference between this texture here, so, and the one in a linear distribution is just a matter of the rearrangement. Okay, and what if we build a new V, and we rearrange that UV, and we use that texture to remap our inputs. Okay, so let's do that. Let's use a ramp. Okay, so ramp, and for the resolution we go with this map here. Okay, we need that 32 mono and nearest pixels. Okay, now we use flip top, and also this one is bottom left, and also nearest pixels. Okay, and now reorder, and this would be 32 RGB. Okay, and for green, second input, and for the blue, now in fact this one should be just 32 RG. Okay, yeah, and we have this UV right here. Let's use a null, And let's copy this folder here and use it for the UV. Okay, now obviously something wrong inside, since we getting out some values for the blue, and let's correct that. Here we only take RG, so it's already much optimized, this method, and here we'll take RG. Okay, and now we good. Okay, and let's use a remap top. So remap top. Okay, and for the resolution, we would like to have the same as this UV line here. So let's use this map here. Oh, not yet. Let's set the remap to custom resolution first, and now here we'll use the square expression, and here is just 1 pixel. Okay, the output aspect would be the same as resolution. Okay, and now let's choose nearest pixels. Okay, now we have the same texture as here, you see, and actually not yet, we need that group. Okay, so now we got it. Let's delete now these bases because we don't need them, and also we need another remap, okay, for the radius now, and this one will go here in this group. And now we are much more optimized. Okay, and you can go with this. Is quite nice and fast, and but what I want you to see is this similar, if you like, pattern, and for a better visualization, let's grab it. So let's select, okay, because I'm curious how this look like in RG splits. So we use reorder, okay, and I'll take red, and this one is 32 mono. Okay, let's go for nearest pixels. Okay, and I will have this red since it's for the X, and now Ctrl C, Ctrl V, green, and now take the green, and it looks like we only need to build those two texture, and we don't need any chop there. Okay, yeah, let's have this instead. So that would be the maximum optimization, since everything is done out in tops, right? Okay, so like here above we need this ramp, but so Ctrl C, Ctrl V, this ramp should be 4 by 1 here. Okay, and out of here we need a fit. Okay, and a transform. Okay, let's have both of them nearest pixels, and for this fit let's set the resolution. It's a map square by 1. Okay, and yeah, this one also. So custom resolution, Control V and 1 here. Okay. Good. Now this fit should be on fill. Okay. So we already have the green. Okay. Let's have this also green color. Let's switch the position. Okay. This one is red. And this one we only need to scale it on X. So for the scale we use the same map value here. Instead we'll have 1 divided by. So here on a pivot we go first, let's set this to repeat, and the pivot should be 0, 0. And what else? On aspect, output should be resolution. Okay, now we good, and we need reorder. Okay, this one will take the input 2 for the green, nearest pixels, and should be 32 RG. Okay, now with only 4 operators we have that texture needed for remap. Okay, so let's use that. Okay, I will delete this and okay, delete also this. Okay, and now we good, and now we quite optimized, I would say. One minor thing I would like to do is use only one remap instead. So let's use a remap and have a texture with position and radius. Okay, the radius will not remap, sorry about that, it's a reorder. Okay, so for the alpha we have second input, take the red. Okay, nearest pixels, and here should be 32 RGBA. Okay, now we use remap, and also the group will solve for the radius too. And since we need radius and positions for 2 separate tasks or more, in the end I would like to have them split. So I use now reorder. Okay, here, and I would only take RGB out of this. Okay, and another one in which I would only take the alpha. So alpha, and this would be mono. Okay, so now, okay, we don't have this matte we need, and we can use it here. Okay, now we good, and yeah, now we quite optimized. And let's have this in in a folder, you know. Let's say we have some minor changes to do. So dot dot slash, and also here and here. Okay. Good. Now that we have the input quite nice, we'll do the same as in previous tutorial, the one with collisions, and have a folder here. So let's grab a base. Okay. If we split the screen, top, bottom, and go inside, now I need here two selects top. So, and I'll take position and radius. Okay. And let's close this. Okay. And now let's do the mod now. Okay. So we have these points. Okay. Let's use a fit. And this fit, oh, I will split again the button to have this open view. Okay. So for this fit, I will take the count and nearest pixels and fill. Okay. So now I'll use a flip bottom left, also nearest pixels. Okay, and now subtract. Okay, and also nearest pixels. Okay, so now I have differences, subtract differences on x, y, z for each possible distance between my points. So for example, on this vertical column right here, the first one, I will have the results of subtraction in each pixel. So now if I use mod top, and let's go for nearest pixel. Okay, and this one should be 32 mono, and here we need to do square, add root, and mask alpha. Okay, and now we have all the distances, right? And we need to find out when we have an overlap. So an overlap would be if the distance between 2 points minus the sum of the radiuses for the sphere. And yeah, let's have that also using again a fit and a flip. Okay. And now we need add. Okay, let's have this nearest pixels also. Okay, now we subtract the sum of the radiuses out of distances. So okay, and this is where we have the offset, and now we need to use a math and take half of that offset. So we multiply by 0.5 here. Okay. Here in the subtract top and the math top, let's make let's have these values normalize. So I will use a composite here out of the subtract, and we need divide and input 1, and now we have normalized vectors position. Okay, and let's multiply this with the half of the offset, so multiply, and you notice now we do the math for all the pixels, for all the points, and we need to do that only in the case when we have the overlap. So we can find out here, if we use the math, okay, and let's grab floor, and here it's 1 0. Okay, nearest pixels, and here for each white pixel we have a touch, an overlap. Okay, all of them but the diagonal line, which is the duplicates, the cases where is the distance between ball index 1 and itself. So we need to take care of that diagonal, but first let's use a level here, since it's possible to have values bigger than 1. So and now I would like to multiply this texture with something that will take care of the diagonal. Okay, so let's use a rectangle top. Okay, the resolution would be the same, so count. Okay, and here in pixels we need actually we need a line, so we'll have only 1 pixel on a second value, and let's go for nearest pixels, and now 12 here. Okay, and what if we rotate 45 degrees? Okay, now yeah, I will not stay to have the exact values to fill this diagonal. Instead I will just multiply by 2, and we have it. Now we need this line to be black 0, so let's set this black, and background would be white alpha 1. Okay, and 32 mono. Okay, now let's multiply this. Okay, now I only have spheres touching and not duplicates. Okay, what we need to do, so all the math here we only need where we have white points. So yeah, let's multiply those two like that, and Okay, now we need to analyze, so we use okay, so we use analyze, and I would like to analyze each row. Okay, and with average. Okay, now I need math, and I would like to multiply that average by the count. Okay, let's have all of these nearest pixels. Okay, and I also need to flip this. Okay, bottom left. So here I have the values, the correct values for the points after overlap it's solved, and those values I need to add them with the input noises, so the first positions. So let's select this operator here. Okay, only to avoid to have a long line between those two operators. So like that, and now we use an add. Okay, again nearest pixels. Okay, and let's see. Here we have all the 12 points. Let's have the same kind of texture which tell us where we have hits. So we use again analyze, and we go for rows, but instead average we take maximum. Okay, and use a flip, bottom left, and let's have a look here. What I want to have is these new positions, if you'd like. I wanna have a texture with transparent, zero, empty, where we don't have hits, and that one will always each frame will be put it over the input noise. That's why we adjust for the position each frame. So for that, let's have those two multiply first, like this, and also reorder, and use this one for alpha, and this one should be RGBA. Okay, let's set those two nearest pixels. Okay, and out we use an out top. Okay, so you see I only have values for cases where I have hits. So what we do now is use a null, and here let's have first a constant which will be the same resolution. So in this case, count by 1, and this resolution is 32 RGBA. Okay, and 0, 0, 0, and alpha also 0. Okay, and use the feedback. Okay, I will have this black and also keyboard in, and use that value also for reset and for pulse. And now I want to use an over. Okay, and this is RGB. I just want to check if I also have alpha here, so I can set this to 1 and have RGBA. Okay, and now we good, and we only need to take this null into feedback. Okay, so what happened with our balls? They stop, and sometimes they change position, but this is good. Okay, let's close this. Okay, and let's play with some parameters. Okay, so first one, let's try to reset this. Okay, so okay, let's see what we have here. Is here in this mat, where we like to have the offset till the spheres don't touch, but actually that value here is exactly the same as they were touching or not, are very close to each other. So if we only multiply here some, I don't know, multiply with no, divide, count, divide by 10, divide by 10. Okay, oh, sorry for this. Oh, I need a parenthesis. Okay. Now, what's happened now? They separate much slower. Okay, and what I want to add is a value which would be separate till you reach that value, which is a little bit bigger than their radiuses. So here I'll have a parenthesis. Okay, and I just add here 0.001. Okay, yeah, they're starting to stop, not just not as fast. Okay, and now what we do now, let's make this noise with radiuses also moving. So we use the same speed for the translate on Z. Okay, so, and now you noticed everything it gets adapted according with the input values. And let's see if we change that I don't know, math multiplication. Let's set here 2. You notice they separate very fast, and sometimes you get a little flicker, but if you have here a good number, everything will be good. And now let's check if we can go crazy with this. So what if 1024? Okay, so yeah, no problem, right? And what if 1024 multiplied by 2? Again, 60 fps. So it's very fast, this this method. Okay, and yeah, that's pretty much all the tutorial. I don't want to get into texturing right now. I will cover that in the next tutorial. So yeah, I really hope you like this, and thank you again for your support, and Happy New Year, and see you in the next one. Bye.